So with standard form, it's going to be either one of two things. Whether they give you a function or an equation, it really doesn't matter because it's going to be basically the same thing either way. It'll be f of x or y equals, and it's going to be something like this, where you got ax squared plus bx squared plus bx plus c. There are no parentheses for one like this. Now, sometimes it may be that, it may just be ax squared plus bx, where the c value would be 0. It could be something like that where it's ax squared plus c, but you have to have at least something x squared, and then, whatever you got past that, there may or may not be 2 or 3 terms, just depending on how it's set up for this one. So the big thing is when you do this one, the a and the b and the c values, it's not a big deal yet, but we'll talk about that very shortly. But a, b, and c are real numbers. And we'll actually talk about imaginary numbers next week. Because you may be going, well, I thought everything was real numbers. Well, we'll show you some imaginary numbers when it comes to it. So, all right, so here is the big moment. Put a big giant star by it. This is the big thing we've got for today that we got to make sure that we have there. So again, this is the moment of the day. Okay, so to find your vertex, which is the h and the k. Still going to be the same thing. We're talking about vertex. It's still the hk if we're looking at it for that part of it. The h value of the vertex is equal to negative b over 2a. Now, and we're going to do this. That's the way the book has it written. We're going to do one little extra thing here. Go ahead and put your a and b in parentheses. Because what throws people off when they get to this one is that negative up here. The bottom part doesn't really throw people off. It's the negative that's here. So if your b value is already a negative number, it's going to be minus a negative, which will make it a positive. And if the b value is a positive, it's going to be minus the positive, which will make it a negative. So it's always going to change the sign of your b value, what it comes down to. Okay. To get the k, which is your y value, this one's not, because the h value really easy. Negative b over 2a, just plug it in, simplify it. You've got what you need for that one. To get the k value, you have to evaluate. Again, evaluate means you're going to plug it in. The negative b over 2a number for x in the original equation. Okay, and if there's any good news with that one, when you get to this part where you have to find the k value, that is pretty much a calculator. If you want to kind of make sure you've got everything lined up and everything's going well, you can pretty much just use your calculator for that part. I would say go ahead and do this one by hand because it's just a really simple fraction anyway. But when we get to this part of it, we can definitely use a calculator to kind of speed that one up. Now, if you're looking in Math Excel, if you're looking at anything reference-wise for books and other stuff for this one, the book notation for this part, or Math Excel or anything else, pretty much every book has the same notation for the vertex. So instead of having h and k, when they show it this way, they're going to basically show it to you like this. That the h value would be negative b over 2a. And then to show the k part, which is where we're going to plug this back in, they're going to put f of negative b over 2a. Yeah. So if you're looking at the show me an example, if you happen to be looking like, let's say if you get stuck on something and you need to look at Khan Academy or some other website or whatever it is that you're looking at to kind of get some different notes on this one, that should be the function notation that they'll show for finding the vertex in standard form. But again, the big thing is being able to find the negative b over 2a. If you can find that part of it, everything else is basically the same thing. Okay. Now, of the three variables or the three numbers, A, B, and C, we're looking at back here. We haven't done anything with C, correct? That we use A and B to help us find the vertex. So here's what C is going to be. C is the y-intercept. So when you're plotting these points, sometimes when you're going through these, once we get the vertex, we have to find at least one more point to be able to plot these. A lot of times you can use the y-intercept to plot that extra point so that you can make the graph go and be what it needs to be. Especially if that A value is a fraction, if you've got the C value, that should be a little bit of a shortcut to speed this process up when you're finding that at least that one extra point that you need to look for. Okay, and again, still remember that your A value still determines everything direction-wise. So that part of it is still, again, still the exact same thing that we're going through here. That if A is greater than 0, we know the graph looks something like this. And if your A value is less than 0, we know the graph will look something like that. And again, here we know this would be a minimum. And here we know that that would be a maximum. So that part of the A value is still the exact same thing. It's still going to give you the direction the graph is going to go, or open, or how they say it there. It's also going to help you know whether you need a max or a minimum based on the direction the graph is going. So that part's still the exact same thing. Okay, so what we're going to do, we're going to graph probably 2, maybe 3 questions, show you what these look like. And once you've seen 2 or 3, you've seen basically everything they can possibly throw at you. So we don't have to do 4, 5, 6, 7, 8 examples. Give you 2 or 3. If everything seems good, then we turn you loose and let you go through the homework and see what you can come up with. All right, so we're going to find a bunch of stuff here. We're going to find, obviously, first the vertex, because again, that is the most important point that we're going to look for. We're either going to find the max or the min and its value. Let's see, what else do we need? We need the axis of symmetry. We need the y-intercept. We need the domain and range. Something we're going to do for this one. We're going to write the equation in vertex or graphing form. And then finally, we're going to graph it. Okay, and again, we're going to do 2, maybe 3 examples because again, everything after that is just a repeat of the same things that we're doing. So there's no need to put, 4, 5, 6, 7 examples for this thing. All right, so for example 1, we go f of x equals 2x squared plus 8x minus 1. Okay, and let's make the easy things the easy things. Tell me what the A, B, and C values are. So we know A is 2. We know B is 8. And we know C is -1. And again, with the C being -1, that part we know that that's going to be the y-intercept right off the bat. And I think in this case they will let you just put -1. I don't think they make you write that one in ordered pair form. I think you can just put -1 for that one, I think. Test-wise, I know that's okay with me for that one, just to put -1. Math Excel still might make you do an ordered pair form, but if they do, they should tell you to put it in ordered pair form. All right, and again, A value is 2, so we know it's positive, so we know it would look something like that, which puts the vertex at the bottom, so we know it's going to be a minimum. All right, so we need negative B over 2A. Again, it's not a big thing, but it does help a lot for that. When you put the A and the B and plug it back in, let's use parentheses. So that's the negative of 8 over 2 times 2. So negative 8 over 4, so that's -2. Okay, so for the vertex, we're halfway home. We've got the H value of the vertex at -2. Again, to find the rest of the second half of the vertex, which basically be with the Y value or the K value. Put a K there. That's where we're going to take this -2 and we're going to plug it into 2x squared plus 8x minus 1. Okay. And again, if you use parentheses, when you plug these numbers in, you can use your calculator, and as long as you don't mistype something, I hate to say that there's not a way that you can miss this part of the question to get the K value, but there shouldn't be a way that you can miss the answer for the K value. Again, the only way you can miss that part of it is that either number one, you did this number wrong, or number two, you typed in something wrong when you did this. Because as long as you use a calculator, the math will always be correct, as long as you use parentheses. Okay, so if we use parentheses, we've got 2 times -2 squared plus 8 times -2 minus 1. So it should be -9. Okay, so now we've got our vertex at -2, -9. So we know the axis of symmetry is going to be x equals -2. We said back up here this was going to be a minimum, so we know that the min value equals -9. Domain, and again, probably test-wise, I'm not even going to ask for domain because it's always the same answer. It's always -infinity to infinity on that one, so I'm pretty much going to skip to the range. And since that's the minimum value for the range, that means we have to start with that number, and then we're going up to infinity. And again, I think Math Excel, a lot of times on this one, instead of doing interval notation, they're going to make you write it with an inequality. And basically on this one is if your arrows are pointed up, it should be a greater than or equal to. So if it's min, it should be greater than. If it's a maximum point, if that's the biggest point, everything is underneath it, so it would then be a less than. Oh, vertex form. Almost forgot that one. Okay, so there's vertex form. So, and again, we're going to leave the y and the x where it is. We have to plug in the a, the h, and the k. We know that a is 2. X is x. The h was -2. So if we do minus -2, that makes that a +2. And then the k was -9, so that'll make it a -9. Okay, and finally we get to graph this thing. Okay, so we're going to 2, 1, 2, 1, 2, 3, 4. Okay, so vertex was at -2, -9, so -2, 2, 4, 6, 8, -9. We put it there. We know that the a value was 2. It's a whole number, so we get that little bit of shortcut. Now, again, here's one thing we could do. We don't have to necessarily use a shortcut because we know that the y-intercept is at -1 from back up here. So we can just go to -1 and use that point. And then, again, that should graph and fill everything in. What we're doing there. And again, if we had an axis of symmetry here, we know that this is 2 spaces this way, so we'd also have to go 2 spaces that way to get that point. All right, now, if you had said, well, what if we used this to kind of help us graph? Well, if we had gone up 2 over 1, it would hit that point there, or up 2 and back 1 would hit that point there. So either way we go, whether we use the a value to help us get to the next point, or we use the y-intercept to get to the next point, it really doesn't matter. We just need a point somewhere that's not the vertex to get us to graph what's going there. Okay. And again, you may or may not have to draw an axis of symmetry. If you do, just go back and draw one. If it doesn't ask you to draw one, then don't worry about it. Test-wise, I'm not going to ask you to draw an axis of symmetry because I'm more worried about everything else that's going on. I think at this point, y'all are pretty much okay with axis of symmetry stuff. Okay, everybody all right with that one? Okay, so let's do this. Let's do one more. We'll do this one with a fraction so that we cannot do this shortcut like we did with the 2. So if we do one with a values of fraction, we're going to have to plot some points, do something different other than just moving, kind of taking our shortcut and cheating a little bit. So this will be a no cheat problem. All right, so let's go. So for our fractions, let's go with -1/2 x squared minus 2x plus 5. And still find all the same things. We're still going to get the axis of symmetry, the vertex, all those different parts and pieces that we're looking at. All right, again, get the easy things out of the way. We know that a value is -1/2. Again, being negative, we know the graph will look something like that, some way, shape, form, or another, which means the vertex will be at the top, which means it's going to be a maximum. Now, if you want to kind of go ahead and do this one, this might be a good thing too. If you know it's pointed down when you talk about your range, you know it's going to be y less than or equal to something. Because again, if the arrows are pointed down, range is going to be less than. If the arrows were up, it'd be y greater than. So you could probably go ahead and again, that's one little extra thing you can add into this one to kind of speed things up a little bit. The b value is -2. C value is 5, so we know that is the y-intercept. Okay, so again, the h value is -b over 2a. So that is negative minus -2 over 2 times -1/2. Okay, top part, minus negative makes that a positive 2. Half of 2 is 1. And a positive times negative on the bottom makes that a -1. So that's 2 over -1. So that means the first part of our vertex is at -2. And again, what we're going to do is we're going to take that -2, the value that we get here, plug it in for x back in the original equation. And again, if they give you f of x in the original equation, just go ahead and rewrite it as y equals, technically, again, that's your k value, because it's the y value of the vertex, so you can also write that as k if you want to. All right, now here's where, now the fraction one, you gotta be a little bit careful in that case. So if it's this one, if I'm plugging this one in, if it's -1/2, you might want to go ahead and put that -1/2 in parentheses. So you may want to do a -1/2 and then do parentheses, -2 squared minus 2 parentheses -2 plus 5. Okay, that should be 7. Question. All right, so if we work this one out just by hand to make sure we've got it, we're going to do -2 squared to make that 4, correct? So then we've got -1/2 times 4, which would be -2. We've got -2 times 2, which would make that a +4. So on the back end, we've got 4 plus 5, which would be 9. So -2 plus 9 would make that to be -7. Okay. Sorry, not -7, +7. Okay, now, and for these, if you do have a value that's a fraction and you're plugging this in the calculator, you have to put that number inside the parentheses, because if not, it's probably not going to read it correctly. So that's the one small thing you might have to do. Now, if you've got one of the Casio calculators, it will actually, put a fraction in front of the x to let you do that. But again, if we're looking at this one, if you have a fraction, just put that number in parentheses in the fraction to let you know what we're looking at there. Okay, so there's our vertex. It's at -2, 7. We know the axis of symmetry. X equals -2. Back up here, we said when that was a max. So the max value is 7. Again, domain. Oh, sorry, y'all can't see that. My bad. We know domain is infinity to infinity, so I'm not even going to worry about that one, because again, test-wise, I'm not going to worry about that. The range in this case, again, if we sneak back up here, this was y less than or equal to our max or min value, 7. And again, if you don't want to use the inequality, I'm okay with you putting -infinity to 7. Okay, we've got our y-intercept back here at 5, so we're good on that part. All we need to do is plug it back into the graphing form thing that we're looking at. So, for that one, that was y equals a times x minus h squared plus k. Our a value was -1/2. It's x minus -2. So if we do x minus -2, that makes that a +2. And then the k value is the sign that's there. Okay, and then last but not least, we need the graph. All right, so we're going to -2, 7, bringing this thing down. So we need x, y axis, a lot of room over here. So there's okay, so -2, 7 will put us there. All right, and again, because this was a fraction of -1/2, we cannot go down 1/2, because that will give us the incorrect number. Normally, this is where you would have to plug in values, but knowing what we know now, that we don't have a y-intercept here because of the way this thing is written. But back up here, we said we knew this thing would cross over the y-axis at 5. So if that's our first point, negative 2, 7, we can just go to 5, and we've got our next point without having to plug anything in and evaluate anything else. Okay. Now, if we did have an axis of symmetry here, we could see that this is 2 spaces this way. So if we were trying to draw this and make it symmetrical as we can, we'd also need one over here, 2 spaces that way. Okay, so we have a graph that looks something like that. And again, because it's 1/2, it's going to be a wider graph because we're making it basically half as tall. We're squishing it a little bit. We're compressing that graph, or dilation, however how you want to word it as we go through this.